Today's episode is sponsored by Castrol. Visit them at castrol.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. Don't forget to like and subscribe to get new episodes delivered to your feed each week. I'm David Muller, Senior Editor at SME Media, and I'll be your host today. We're joined by Greg Davidson, Aviation Specialty Manager at Castrol. Greg has been with Castrol for 12 years, and in addition to aviation, he's had roles in industrial sales, engineering, and technology, but he is a self-proclaimed aviation geek. Thanks for joining us, Greg. We're glad to have you here. Welcome to the show.
Thanks so much for having me.
Absolutely. Our pleasure. Could we maybe start by just giving a little bit more background on yourself and your role with Castrol?
Yeah, so like you mentioned, I've been with Castrol for 12 years. And the last 4 I've been really focused on our aviation specialty products, which are part of our industrial group. Those products we consider to be flyaway products. So they're not part of the manufacturing process. And it takes me to a lot of different cool customers around the globe, but primarily only focused on aviation or aviation-related applications such as ground support equipment, et cetera.
Yeah, they're not really fluids just found in engines, right? I mean, it's everything else that you can imagine, maybe in addition to engines or landing gear, things like that. Is that correct?
Exactly. So it's everything at Castrol that is not an engine that would be related. We call them flyaway fluids because they're not used in the manufacturing process like our traditional industrial, cutting oils or hydraulic fluids in that part. These are actually used on the piece of equipment after it's finished for it to perform its work over its lifetime.
And I mean, it's obviously it's something that maybe, people in general, if they're outside of what you do, obviously getting on and off a plane, don't necessarily think of, but they're obviously very crucial to the operation and safety of an aircraft, right?
Yeah, I think a lot of time is spent around how do you make a part or how do you make an assembly, but we don't necessarily focus all the time on what happens that after it's made and it's put into service, it still has to perform what it's been designed to do for years, right? And so it's all about taking that application, matching it with a product or designing a product around it that can help that piece of equipment last.
So how do customers, if I'm a customer in this space, how do I decide the optimum lubricants for whatever application I'm using? Because the applications range from, like I said, landing gear, but they also use them in not just aircraft, but missiles and things like that too, right?
Yeah, it's pretty cool. So it all starts with the details. And this is where the challenge really comes in, right? So much of what I do, I cannot be told what it is, or it's super proprietary to that company. So we don't get a lot of those all that time. But you get what you can. You kind of look at things like speed and load and temperature and what's it doing. They're kind of the have-to-haves. And then you get the nice-to-haves of, well, we want it to store it this way. We want to maintain it at X interval over time. So we do, work alongside our customers, our engineering staff, our technology staff gets involved. And we find that product or a couple products that we want to try and test. And then from then it's all about testing, right? We can get in there into testing. Sometimes it's, hey, run this specific test and we're going to use it if the outcome is X. Other times it's, hey, let's put it in this test rig that we designed, the customer, and we're going to test it for 5 years. And I'm in one of those right now where we started testing. It's my very first year on this job, and we hope that test finish next year with positive results. So, it's about kind of finding that balance of where you think you need that performance to be, because unfortunately, there isn't one perfect product, right? If we had that, I think whoever company had that would be the top one, and everyone else would try to copy that. But so it's a give and take.
Yeah, absolutely. I mean, so you mentioned that the testing lasts for 5 years. That's pretty interesting to me. Can you talk maybe a little bit more about why the testing process is so long?
Yeah, I think there's a bit of proof of performance, right? Where you could do so much stuff in a laboratory, but you can only do so much stuff in the laboratory, right? And so our customers have got these pretty advanced test rigs now and the capability to design and build test rigs that can give them more, I would say, real world or applicable data. And so they may say, hey, in this, gearbox or something, we want so many cycles. And so they're able to either designate a gearbox or build a similar gearbox or smaller gearbox or whatever. And we can test that in that for X number of cycles. And in the one I'm talking about, it's strictly cycle count driven, right? We want to get to, thousands of cycles per, for this thing to work and prove it out. So they're willing to do that, right? Let's just take the time to do it now. That way we know as that aircraft or whatever piece of equipment moves forward, it's going to work.
And it's not just the cycles, right? I mean, it's also the differences in environments that these aircraft I would imagine, come into contact with, like a plane going to Alaska one day and Miami the next.
Yeah, let's look at landing gear, right? I think that's an easy one to talk about for us. That's kind of in our wheelhouse. Let's look from Alaska. A plane is, I tell my team this all the time, it can land in the freezing cold Alaska in January, daytime where it's completely dark, and land there, unload, reload, whether it's cargo or people, and take off heading for Miami. So let's look at that, right? And let's look at it through like a landing gear lens. So you take off, it's super cold, it's negative whatever up there today. You want that, if I've got passengers on board, right? You want that ride to be somewhat comfortable. So you've got to be able to like have a fluid that is thin enough that at that temperature will kind of absorb that like shock and stuff from taxiing down the runway and ramp it up to takeoff speed. You take off, it's super cold. You put the wheels in the wells, you fly down to Miami, super good flight. You've burned a ton of fuel. Your weight's totally different. But now in Miami, when you land down there, it's 90 degrees. And so again, that super thin fluid that you had couldn't be so thin that when you land at Miami, you still have to have, some fluid film thickness there. You still have to have the additive package that, as you land that aircraft, it takes pretty much all that weight pretty well instantly, right? You don't get this long lead into a landing. You pretty much stick it and you're down. And so all those things have to be kind of taken into consideration. And then you got to repeat the process like, hundreds or thousands of times, right? And I've got customers that have told me that their landing gear, they expect to take, taxi 50 some odd thousand miles over its lifetime. So, you can protect it once. That's kind of an easy thing to do, but it's repeated protection is what we're really trying to go after.
Wow. Awesome. Okay. Yeah, so I imagine that also, in addition to the length of time that you're sitting here and testing these fluids, there's probably specific certification processes that they have to go through before they're approved for use in aviation too, right?
Yeah, that's totally true, right? I like to tell our team that, we test a lot of products, but our customers are going to do that much more testing, more or the same amount or more, right? We're absolutely going to test and approve and stuff like that. So most of the OEMs, like, they kind of set their own standards, right? They have the specifications. Our customers know their systems and designs better than we ever will, despite, we know a lot of them pretty well, but they're always going to be the experts. So we really rely on them of, hey, what do you want to do and what are you exactly looking for? But, so they design the part and then they kind of this suite of testing. We can kind of go through that. We can tweak additive products. We can tweak the base oils, this, that, and the other to kind of meet those demands. On the other side of that is actually the military, right? They're probably the largest kind of approving body of a lot of these products, right? With the mil spec. Everybody comes to me with a mil spec. And so, working with those guys, you gotta get your approvals, you gotta do all the testing, and they kind of repeat the process. So it's really lengthy, it's kind of costly. You don't want to do it all the time if you don't have to, because there's a ton of costs associated there. But the approvals are really kind of the license to operate.
Yeah, and I mean, with the rigorous testing and quality control in place, what happens then later if an issue arises in the field after a fluid has been approved for use? I mean, how do manufacturers like Castrol handle like an unexpected failure or challenge, or what steps are taken to ensure, further improvement and innovation in fluid?
Yeah, I think those are somewhat two different sides of it, right? So I'll take the first side. What happens when something goes wrong? Because it does inevitably, right? And it can be really challenging. It's really tough to get to an answer because there's so many variables. Some customers are very quick to blame an oil. Some customers will never blame the oil. It just kind of depends on what the failure mode is, right? But it kind of starts with a sample, right? Can you get a sample from it? Can you get a piece of equipment back or a bearing back for inspection? If you had a catastrophic failure, some of that is kind of gone, right? You can't really inspect or kind of perform a root cause analysis on it. But to try to isolate as many variables as you can. We've got a great team of technologists, other companies, great labs in the U.S. that are third-party labs that we partner with. And then the customers too, right? They've got their in-house labs. We do a lot of like joint investigations with what went wrong. You try to fix it, right? You try to move forward with, like you said, like a design. Can we tweak something? Can we get more additives? Can we get less additives? Is this failure mode something we predicted? Or did it just kind of, was it a one-off? Was it, I had a customer recently that put a seal in wrong. So, that was a major catastrophic failure that, we can fix that.
Are there certain trends in terms of like the actual chemical makeups of these fluids, or has it kind of stayed the same since, the days of Bray oil, or are there new developments happening nowadays?
Yeah, I say it's a bit of both. Certainly we have some like legacy technologies that are going to be around forever. They've been around for a long time, and I don't see them going away. But there's also that kind of new trends of everyone wants to go faster. All of a sudden, they want to go higher, and they certainly want to go more fuel efficiently, right? And more, kind of net zero, carbon neutral. So I think we're looking at a lot of those things like weight, base oils. How can we change and still get the performance? Because the one thing they don't want to give up is performance, right? You can have a great, carbon claim or whatever you're looking for, but if it doesn't perform, you're kind of back at square one.
And one thing, just for my own understanding here, as a side note here, we, like you said, we talk about landing gear. You mentioned some of the different applications, but can you kind of talk about like what are the aerospace, like the missile and defense application? How is like a aviation fluid used in like missiles, for example?
Yeah, I think there's a lot of things like, actuators and hydraulic systems that still have to perform work, right? It is not necessarily, they could be on the missile themselves, or they're on the ground equipment to get it where it needs to go. Most of these pieces of our equipment are pretty big. Despite looking really small in like a YouTube video or something, like these rockets are massive, engineering marvels, right? So the amount of work there that needs to be done, it may only be like, fins or a small valve that needs to be turned. But you got to do it, and you got to be able to do it reliably.
Interesting. Okay, great. Appreciate that. Looking ahead, we talked about some of the trends for the OEM expectations, but what do you think are going to be some of the biggest challenges shaping the future of aviation fluids going forward?
Yeah, that's a great question. I think I spend a lot of time thinking about this. We're certainly in a new kind of design era. A lot of this stuff has been, if you look at like a tube and wing thing, that was how it's designed in the 50s and 60s at the dawn of the jet age. We're starting to kind of maybe look past that, right? Think of like the CFM and the Rise open fan architecture. You think of like SAF coming in, the blended wing design. I think a lot of this stuff is going to have new systems that we don't even know of yet, right? Some of it is going to be done with kind of legacy products or products that we have that we can tweak now, and synthetic base oil technology is fantastic. So I think a lot of that can be done, but there's a lot of things that we don't know, right? Electric travel by air. These more operate, similar to an electric car. They operate more like that than on a plane. So it's going to be an interesting few years, I think.
You mentioned that's interesting. Also, the kind of thinking of the electrification. It's not, obviously it hasn't arrived as much in aviation, at least from my limited perspective. I don't know as much about aviation as you by any stretch of the imagination, but I mean, is it something that you see as kind of growing, electrification in aviation, just kind of as a side note?
Yeah, I think it certainly is growing. I'm interested to see if it actually takes off. No pun intended there. But it's a lot of different challenges, right? The mobility standpoint is fantastic, right? They're smaller, they're more nimble. You can go anywhere. I live in Chicago, so it's like a major metro area. Could we have like little ports? But then you kind of got the other side of that, right? Where with that comes noise. Some of these designs have 8 and 10 electric, rotors on them. Like those are going to be fairly noisy. I hope one doesn't get installed next to my house.
Yeah. And then I imagine like the weight of the battery that to power it, limits what you can do. And then you limit the range if you have a smaller battery and
then the charging as well. So like, that's what we're seeing kind of in its spaces, where some of the traditional aviation lubricants, maybe they won't have a use. We're starting to see some of like the thermally managed batteries. Like you got to be able to charge them. No one wants to wait 24 hours or something to charge anymore, right? So that thermal capacity. And so can we use some of our like or thermal management fluids in these applications, which so far we've done some tests and it's looking pretty good, but that space just hasn't really taken off yet.
And you kind of answered part of my next question, which is really, and you mentioned this earlier, if, with the automotive industry's shift to EVs, uneven shift, you talk about, you're not going to need engine oil, obviously more, but obviously there's other things that need to be lubricated, and the same, I imagine, in an aircraft. I mean, is that the case? Like you mentioned a couple things there. I mean, looking ahead, if let's say like the aviation, sector does go more heavily electrified, how does that affect the aviation lubricants and fluids?
Yeah, it certainly changes the landscape. You're looking more at like thermal management, fluids for batteries. You're looking at greases for the rotors and for the electric motors. You may not be looking at hydraulic systems as much, which is good and bad, right? Everything's going to be a trade-off.
Yeah, definitely. All right. Well, with taking everything into account, whether it's environmental regulations, advancements in materials, new technologies, I mean, what is Castrol doing to just kind of stay ahead of the curve here?
Yeah, I think we're doing it all. We're looking at everything, and our customers are asking us to. Can we look at base oils? Can we change a base oil here or there? Can we get a lower carbon, kind of claim like some of the Castrol More Circular has done in the automotive space? Can we bring that to aviation? We need to do a lot of testing, but we're certainly starting to look at that. We're also looking at things like our packaging, right? Can we reduce? Can we make it easier for our customer? Can we make it easier from a handling perspective? Can we get it in a package that is a lot more ergonomic for people on the front lines? Net zero, I think everybody's talking about that with SAF and stuff. We're not really playing in that, but I think that's going to change aviation. BP as a whole is playing, but not something that kind of falls to Castrol. And then the testing, I think the testing has been kind of just what's changed so much since I've been at Castrol. New test rigs, customer built test rigs. We're learning a lot more about these fluids than we were, 15, 20 years ago, which is really exciting. We found new applications for old fluids. And then we've also, been able to kind of tweak design, new fluids, new additives, just because we're getting better test data.
Excellent. Hey, Greg, I want to thank you for taking the time out of your day to join us for this interesting conversation. If listeners want to learn more about Castrol, where should they go?
Yeah, head to our website, right? Like everybody else, we've got one of those, castrol.com/aviation and then -US.
Perfect. And to learn more about the latest manufacturing trends and to hear more podcasts, don't forget to like and subscribe to our podcast feed. And to stay up to date about what's happening in manufacturing today and hear more podcasts, visit us at advancedmanufacturing.org.